Alright, y'all, I am back, although with a pretty nasty cold. So I'm home from work right now. I took the day off. Doesn't appear to be COVID. At least all the tests I've taken so far have been negative, but it's pretty, it's a pretty nasty one. But anyway, I just wanted to do a follow-up video on this SG503 from Tektronix, this leveled sine wave generator that I did a couple videos on repairing. And in the last video I did, I declared that it was fixed. You know, we saw that it was clearly one of the 7490s that went bad, that was preventing us from getting a readout on the frequency display. But at the end of that video, I measured the 5.2 voltage rail one last time, and it was still about 4.7 volts. Now, I had looked at that circuit pretty thoroughly, and I couldn't find anything wrong. So I had speculated that maybe it was because we're powering this SG503 from a TM5000 series mainframe and not the 500 series, because the 5000 series provides a much lower supply voltage. But that actually turned out to be false. So I had been updating the progress of this repair in one of the forums that I'm in, TechScopes, and someone had mentioned they actually put this power supply circuit with this LM723 in a simulator and determined that with the supply voltage that comes from the TM5003, this negative 25 volts, at the input of this LM723 in this SG503, should still be able to provide easily negative 22 volts, and it wasn't. So I started having another look at things. I checked all of the resistors in the voltage dividers that make up that are utilized in the LM723 regulator circuit. They were all within spec. I replaced the reference capacitor C697, another tantalum cap that was completely fine. That didn't do anything. And so finally, I decided to replace the LM723. I actually had purchased some with the 7490s. I had considered that being the a potential cause because there was nothing else left. So sure enough, replacing that brought the power rails back into spec. Okay, so that's measuring the 5.2 volt rail. Now, the service manual indicates it can be anywhere from 5 to 5.4, so I just left it there. But yeah, it was the LM723, which, I mean, it was 50 years old, so, you know, but the thing is, you just don't, that's it right there. All right. It's rare for the voltage regulator IC to be the cause, in my experience. So it wasn't really the first thing that I thought of. But that was it. And so when I removed it, I actually put it in a breadboard and built a circuit. So I built this test circuit that the datasheet for the LM723 provides. And this is actually the STM LM723 datasheet. This is the circuit that they claim to use to get all of their electrical characteristics parameters, or at least some of them. And so I built that on a breadboard to see what it would output. So we've got 12 volts on the input, 5 volts should be outputting. And sure enough, it was outputting roughly 5.5 volts. Again, it was outputting higher than it should have been, just like in the SG503. Another interesting thing to point out is Vref I measured roughly at 7.2 volts, which is normal for the LM723. So it wasn't even the internal voltage reference. So if you look at the uh, internal diagram of the LM723, which is right here, you've got this temperature compensated Zener. You know, you might assume that, oh, maybe over 50 years that could have gone bad or something, but that's still bang on. Really only leaves maybe this error amplifier, something going wrong there. Just an interesting, um, fault. It's just one you don't see all that often. At least I haven't. But anyway, I thought that was interesting to share. And so that fixes the voltage rail problem. Now, there were still a couple other things. So some minor things, like I did mention that this knob was loose, so I tightened that. That's an easy fix. But there was one last thing that was still problematic and frustrating at that. And that is the 10 megahertz setting, or the 10 to 25 megahertz, I should say. So when you set it to 10, okay, you have the ability to adjust it from 10 to roughly 25, and that's actually what we've got now. We're at the higher end of that setting, and it's putting out a stable, leveled sine wave. That's good, but watch what happens as we decrease the frequency. So far, so good. Now, you'll know it's unleveled, well, besides looking at the scope, when it starts blinking the display. Okay. So it hasn't started yet. Oh, there it goes. And you can see it's at the highest output, so it should be 5.5 volts peak to peak, and now it's down to 4.4. All right, but if we go back up, now it's back to normal. Oh, wait, nope, now it's going back down. Hold on. Oh, now it's really unhappy. All right. Okay. Now it's back to normal. So this has been a real frustrating problem. It seems to me now that on this setting, if I drop it below 10 megahertz, from 8 to 10 megahertz, it will start to go unleveled. But anything above that at the set point, it's usually okay. And so I initially thought that it was these cam style switches that Tektronix loves to use. So let's take a look here. You see that? The drum, that's the actuator. If you've never seen one of these before, and then below that you have these gold flags, and they kind of are lifted up, and then you can see these notches. When you turn this switch, they'll come and hit the flags and make contact with the trace or gold pad on the circuit board. Alright? So that's how these switches work. So I thought it was maybe the either a gold flag was bent or it was dirty, something like that. So I sprayed a bunch of contact cleaner in there, compressed aired it, and it didn't do anything. But if it was one of these gold flags that was the problem, it seems to me that that would be affecting multiple settings. And I'll show you why. Now, if you look at the service manual, this is the basically the switching details for that cam switch. And so where you see a circle, that's where contact is made. So this is for example, the 10 to 25 megahertz setting. This is the one we're having a problem with. You can see when the switch is at this setting, 5 is closed, 7 is closed, and 11 is closed. All right? Well, that's not the only setting that has those contacts closed. So does 1 to 2.5. All right? So if that was the problem, we'd have a problem with the 1 to 2.5 setting as well, and we don't. So it's not those gold flags that are the problem. But this switch is just is a 2-in-1 style switch. So if we look again, all right. Oops, sorry. I can't really get a good view of this. It's a little dark, but anyway. This is a rotary wafer switch here, okay? Well, actually, I can get a better look at it from the other side, but I'll tell you why in a second. This is the area, this side is where the problem was, but it'll be easier to show you guys on this side. Let me walk around here. Okay. There's a better view of it. So that is a rotary wafer switch. All right, you can see the wafer right there, and then there's a bunch of contacts that are a little like they are kind of bent up just a little bit, and as you turn the switch, they'll make contact with that wafer switch. I mean that wafer, that metal wafer. Well, one of those contacts was bent up on the 10 megahertz setting. So I removed this entire assembly. All right, that whole A2 coil board, the drum, everything. I had to take off the front to remove it, which was a real pain because these, it looks like you can't, it almost looks like every time they had to take this off, I guess, this was a part you were replacing. It doesn't look like you can take this off without breaking this. I mean, maybe someone can correct me if I'm wrong, but I don't really see a way to get that out without really deforming it or damaging it. But I was able to finagle my way to get this off and keep this as well. And yeah, and I bent that contact back into place. I buzzed it out with my multimeter for continuity, every setting, everything looked good. Installed everything, and sure enough, the problem still persists. So I might have to admit defeat on this one. It's only for a small section of the range, and this is actually more so for testing the bandwidth of the oscilloscope that you're calibrating. So not really too concerned about a 2 megahertz range, especially in the middle range. So I think I can live with this, but hey, I mean, if this is something that you encounter with one of these, you know, I just hope you don't have to deal with taking the whole switch assembly apart. I mean, it wasn't all that bad, but it just kind of sucks when you do all that and it still doesn't work. But yeah. Anyway, that's where we're at with this. I'm still not done with it. I'm gonna perform a run it through the performance checks once I'm feeling better and I'm back in the lab and do calibration on it, and then it'll be good to go. I think I'll be done with it. But yep, just wanted to share that with you guys. Stay healthy. All right, catch you guys next time.